Hi, we're the Big Bang. This is... Say your name.
Oh, Linda.
And...
Hi, Tony.
Your name is?
Ranger. Hi, Tony.
That's
Taryn.
Yeah, in case you didn't know.
Courtney.
And I'm Natasha behind the camera. So...
And we're going to do problem number 61 from chapter 9, rotational motion. And in this problem, we have to find the kinetic energy of the Earth, first due to its rotation around the sun, and then due to its daily spin on its axis. So to find kinetic energy, we can start off with some basic equations. For rotational motion, kinetic energy is 1/2 I omega squared. And I is the mass times the radius squared.
Woohoo!
Omega is 2 pi over time.
Which has to be in
T
seconds.
is the period. Yes, in seconds. And also, so we can just write, substituting in for this, for I, we can write kinetic energy as 1/2 mr squared omega squared. And the rest is about to come.
Okay.
Okay, so we're going to start with part A, which I should probably write part A on here, huh? Okay, and with my little diagram here, it's showing you that the Earth rotates around the sun, and we know that the Earth rotates around the sun. It takes 365 days. So I'm going to write 365 days.
How many seconds is that?
Well,
we have to
Courtney,
convert it to seconds.
I'm going to convert that into seconds like Courtney and Taryn told me to. So we know that there is 24 hours in one day. And so my days will cross out. And we know that there are 3,600 seconds in 1 hour. So my hours will cross off. When I get my calculator and equation that, I find out that time equals 300, no, oops, erase that. 3.153, hang on, hang on, Tony, just hang on a second. Don't get all your panties in a bun.
I'm going to do it, Shannon.
3.15, right?
There's no way it's 3 point.
She's going to do times 10.
Oh, I was like...
7.
Or, without scientific notation.
Or without scientific notation, it is 3,156,192 seconds. Dun, dun, dun.
No, it's not.
Yeah, that's what I have.
No, it has to be 3153, you guys.
I think it's 3156 though. Because I had 3 and I crossed it out.
It's 31536 and then 0000.
Okay.
It's what?
I'm wrong then, sorry. Okay, so now part B.
No, we're not. We haven't even finished part A. You have to, okay.
The goal wasn't to find the second.
Okay, so you're going to calculate the kinetic energy.
Go ahead, Taryn. Take us through this.
Write this down, Shannon. Okay.
We're going to teach you, Shannon. This is what we do in our group.
KE equals 1/2
We already
I.
have all that up there.
Right, okay, so we're going to plug in the numbers.
Okay, so you have T. What can you put T into? You can put T,
T
right
into
here.
omega,
So
right.
calculate omega. That's the first step.
Thank you.
Fair.
Right there.
2 pi. You want to write this?
Come on,
Yes.
Shannon. We're teaching you, Shannon.
2 pi over what we just got for
The
T.
time. 3.153. 6 times 10 to the 7th seconds.
Is omega really 2 pi over T?
Yeah.
This is
And so that happens to equal.
Right? Omega?
Someone with a
That's an
calculator.
I, not omega.
Is the double
Omega? We've got to redo this.
No.
That's alpha. Omega's on the board next to your face. Omega's on the board next to your face.
Equals.
It kind of looks like a W. There you go.
There you go. That's going to be part of the kinetic energy. You're going to plug what you get this into the KE of the Earth. So after we calculate
Okay,
that,
so omega equals, ready for the Shannon?
Yes.
Equals 1.99 times 10 to the negative 7.
Yep.
Yeah, I got 2 points. Yeah. See, I just have different numbers from mine.
What are the units for omega?
Well, it's pi divided by seconds.
Yeah.
Okay.
So rads? No, whatever. Rads? No, don't write it down.
I don't know.
Okay, so now that we have that,
So we have omega.
now we need to calculate I.
Exactly. Here's the equation for I.
It's okay, it can have errors. 'cause
Okay,
this is like what
so
we do.
now
We're learning.
I'm gonna get down on my knees.
Right, I, okay.
Using the mass,
The mass,
of the Earth,
which is known.
which is, what is it?
A given.
It is 5.97 times 10 to the 24. Okay, that's the mass.
Okay, and then the radius, we're using the radius from the
What
Earth
is
to the
it?
Sun. What's that?
It's 1.50. These are all knowns, by the way.
They're given in the equation.
They're
Times
given
10.
in the book that you made us buy.
Right,
Times
times
10.
10 to the 11th. And then we're gonna have to square the second, parentheses.
That's gonna be meters. Put meters right there. And for mass, put kilograms.
Can you see that?
Yep.
Okay,
And
so
then-
that total equals, I don't have it because I have, oh yeah, it's 1.34, yeah, times 10 to the 47,
Wow.
okay? So that is our I.
So now we can plug in
Our
I
omega
and omega here to,
to get the kinetic energy.
energy.
So now,
Shannon's doing good. She's getting it.
we're teaching her.
It's a learning
We're
process.
all working together.
We can't be
Okay,
perfect.
so 1/2 I, which
This is
we
one
have,
I,
right?
exactly.
Very good. Plug in omega.
It's my omega,
1.99. I don't have this, Courtney, so I have different numbers. So I got 2.0 times something, so. Squared?
Yep.
Squared, there you go.
And so
And the kinetic energy is,
Hold on.
we're calculating it.
2.65 times 10 to the
33rd. Yeah.
Joules.
yay.
Alright,
So
so
let's.
we have
So what does that
the,
mean? It takes 2.65 times 10 to the 33rd joules to.
energy to
That's how much-
rotate.
one time.
That's how
around
much
the
energy
sun.
the Earth uses when it rotates around the sun.
Right.
Good job. Okay.
Yay.
That's part A.
Okay, now for part B, we're gonna calculate the kinetic energy it takes for the Earth to rotate around its axis. So instead of 365, we're just gonna calculate how long it takes for 1 day. So first we have to convert 1 day into seconds. So we know that there's 24 hours in 1 day and 360 or 3,060 seconds, right? Yeah.
3,600, yeah.
And 1 hour. And so our hours cancel out.
So
How many exactly?
it equals 86400 seconds. So that's the period.
So now we can calculate
Omega.
the omega, which is so you don't have an hour for me.
Yes, it's 7.2722 times 10 to the negative 5.
Okay, so that's our omega.
No, we need to figure out what I would be next.
Okay.
So I equals, I'll tell you what it is, 2/5.
Oh, we have to use a different I.
Right.
Exactly, because now it's a
2/5
sphere.
omega.
2/5, no, mass of the Earth times the radius of the Earth squared.
Okay.
So there's a new equation for I.
I, right.
Okay.
Okay, and the mass of the Earth was given, what is that one more time?
5.97 times 10 to the 24th. And then the radius of its axis is 6.38 times 10 to the 6 meters. So all that calculated out equals 9.72 times 10 to the 37th.
Is my computer
And what, do you know the unit on that?
Kilogram meter squared.
Very good.
All right. So now that we have I and omega, we can plug it into the kinetic energy
Equation?
formula. Yes.
Okay.
Right.
Sorry, my bad handwriting.
So now we're using the bottom kinetic
So
energy.
now, yeah, right.
Well, we're using the top since we already calculated I, but it's the same.
1/2 I.
Yeah.
The top, oh, yeah.
It's
To
the
do
same.
I.
What is I, okay.
9.72 times 10 to the 37th times omega, which is 7.27.
And we
No,
Wait,
times 10 to the
times
negative fifth.
There we go.
Thank you, girls.
Squared. Plus, there you go. Someone's phone shouldn't be ringing right now.
And now the answer is
The answer that I have for the kinetic energy is 2.57 times 10 to the 29th. So,
That's obviously in scientific notation.
joules.
good job, Shannon. Way to be a joules. So, what that means is it takes 2.57 times 10 to the 29th joules to rotate of energy to rotate on its axis.
Which is much less than rotating around the sun.
Right.
Yes.
Hmm.
Well, because it has to go much less distance, it just has to go.
Rotate.
True.
Like a whole 360 degrees.
What was
Isn't this interesting?
what was the power of the kinetic energy for it to rotate around the sun?
The power?
Like, I mean, this is like to the 29th,
It was to the 33rd.
Oh, yeah.
33rd.
For going around the sun was to the 33rd.
Oh, okay.
Yeah.
So that concludes our problem.
No, we're not done yet.
Oh, we're not done
Part
yet.
C.
Oh.
Oh, our
Oh,
bad.
wait, is there?
Yes, there is.
Yes,
I
there
have
is.
it. So, what does it say exactly? It says,
Okay, so now we're going to do part C, and we're interested in what percentage of Earth's axial rotation, of the total, right? What was the
What
question?
percent of the total kinetic energy of the Earth is
Is
contained
contained.
in its axis spin?
And its axis spin. Okay, so basically we're comparing this spin that the Earth does with, here's the sun, this spin, like this. It's hard to do, but, you know, like you're spinning this way and you're going around the sun at the same time. Okay, so first we need to find the total energy of the sun. So we're going to do that by, we already found in part B what the percentage was for just rotating in its axial.
Not the percentage, just the kinetic energy.
Oh, kinetic energy.
yeah. Right.
So this is what we found. Horrible writing like chicken scratch. Okay. Right?
Courtney! No!
This is what we found. Oh Lord. This is what we found in part
Chicken in
B.
the room! What is that sound?
This is what we found in part B. So we're going to add part B plus part A. This is the Earth rotating around its axis, and we're going to add this to, the energy takes the Earth to rotate actually around the sun. Okay, and then we get this. 2.63 times 10 to the 33rd. This is the total.
Total joules.
In
Total
joules.
kinetic energy.
And so then we're going to take just the energy that it requires to move axially, because that was the question, and divide that by the total. And then we are left with this, 9.77 times 10 to the negative 5 joules. And since we're interested in a percentage, we need to multiply this by 100, which gives us 0.0098%.
So that's the amount that is contained.
Whoa,
Whoa.
Yes, this is the amount that is contained.
That's the percent of the kinetic energy that the Earth uses in its spin.
Just to
Compare the total. So
This isn't even 1%.
You're kind of
Yeah.
standing in front of it. Yeah,
I don't
thank
think
you.
that's right.
So that's really, really little. It's
Right.
such a small percent of energy compared to the total energy that the Earth uses, like spinning and traveling around.
Right. So the axial spin really is
A very small part of the total
very
energy.
efficient.
Right.
So that's it, right?
That's it,
All right, Tony.
Thanks, guys. Hope you learned
Peace.
something.
Bye, Tony.
Bye.
Right.